Hi, good to see you guys again. So, this video I'm going to talk to you about the studio classroom assignment on the snowball effect, the second studio classroom assignment for this course. Together with Katarina Erdmann, who answered a lot of the Q&A questions during the lectures and who will also be manning the discussion board on structures and materials and on this assignment on Brightspace, we have created this assignment for you. In this video, I'm going to talk to you a little bit about what we expect and the things that you should do or shouldn't do, and also give you some pointers and some tips with regards to the exam. This assignment has a twofold purpose. First of all, is to explore the effects of where aircraft fly and the implications that has for the various design requirements of the structures and materials that we use. Secondly, is to actually have you investigate the snowball effect and experience how reducing the weight of one structure can induce reductions in weight elsewhere in the aircraft. What you need for this assignment? Well, obviously all the slides, everything he told you, because I expect you to remember it by heart. No, not quite, but I do expect you to have studied the material in the meantime. The book, Introduction to Flight by Anderson, the selected chapters that we put online of our ebook, pen, paper, and a tablet or maybe even a laptop to do some calculations in Excel or a programming language, whatever you want, a calculator. Most importantly, some people to work with, because really, I said this at class today as well, you learn better together. This was never an assignment that was designed for you to do this alone in a little ivory tower. This was an assignment, I'm going a bit fast, sorry, to do together. It was designed to do with your mentor group. If possible, get together in your scheduled hours, online, with your mentor group or with a smaller subgroup and discuss where you're going, because together you get much better insights of what's happening by explaining it to others than if you go it alone. This assignment consists of 4 different parts, and what we expect at the end is a write-up in which you answer all of the questions that we ask you in this assignment. The parts are cabin pressurization, fuselage stresses, the specific material properties, and finally the snowball effect. In this video, I will explain each part one by one. You can either watch the video in full or pause the video after each part and start working. I leave that up to you. So what we've done is on Brightspace, we've created an assignment, and in the assignment you can upload your results. Please do so before the 21st of September, so that's the Monday at 9 o'clock Central European Standard Time. We will try and look through most of it on a very generic basis to see if there's any misconceptions that many of you have, or whether you're all fantastic, which of course I'm counting on, and try and give you a bit more tailored feedback. Now, as making videos like this does take a little bit of time, certainly the prepping, and if I talk too fast, then I also have to do multiple takes because I lose my words. Bear with us, and we'll try and get it up to you, uploaded to you by 5 o'clock that evening. If not, I'll put a little note on Brightspace to say that it has been delayed. Let me try and talk you through all the different parts, and let's start off with pressurization. Really what we want to discuss here is the why behind pressurizing the cabin. We expect you to be able to use the equations of the International Standard Atmosphere that Professor Hoekstra explained in his first lectures, and to use the data that you see here to do your calculations. Please use this data and not data you find elsewhere, because it makes it a lot easier for us to quickly see how you guys were doing. This section of part 1 has 3 questions in it. First of all, we would like you to explain why overpressure is needed in the aircraft cabin. When we ask you to explain something, we expect you to come to an argued answer. So, because I said so, or because that is what Professor Hoekstra told us in class, are not considered valid scientific arguments. I don't think they were in high school, but they most certainly are not at university. In the second part, we are going to ask you to do some math. We ask you to calculate the pressure difference if we fly at 11,000 meters and we want to have an equivalent attitude pressure of 3,000 meters in the cabin. Then in question 3, we ask you to do it again, but then look at what would happen if we had the cabin pressure as the pressure that we'd have here on Earth. That means math. Please don't just give us the final answer, but write out the formulas in full, then show us how you substitute it and come up with the final answer. Why is that? Because one, it is the proper way to do work. It sounds really childish, but if you have to hand in calculations that other people have to check, and in engineering we check each other's work constantly to ensure safety, people have to understand what you do. So just putting down the final answer is not going to help you. In this case, we know what the outcomes are, but when we go to design, the answers could be open. So then we'll basically reject your answer because there's no way for us to check if the methods you use are reliable. That brings me to part 2, the fuselage stress. Hopefully you remember from today's class that the longitudinal stress and the hoop stress have the following formulas. I'm not going to derive them again. You've seen it done, and otherwise press replay on the video. That's the great thing about having recordings. First of all, we want to talk to you a little bit more about the sort of things like allowable stresses. Why is there a large difference between the allowable stress and the two tensile yield stresses and failure stresses? The second question is, in the next slide I have a table with all sorts of material properties. And we ask you to calculate the minimum required thicknesses for the pressure vessels using some of the parameters you see below. For this, use the equations on on 2 slides previous, and think very well about the composite cylinders. If they're unidirectional materials, do they only go in one direction or in 2 directions? Or more or less? As discussed, here is the table, which is purely there because then you can nicely display a pic on your screen, which is nice if you share it with your friends. And now we go to the second 2 questions of part 2. And here we ask you to plot something. I'm fine if you plot this on square paper. You don't even have to go to millimeter paper or something like that. But also, if you can do it in Excel or Python, Maple, whichever is your tools of the trade, that's great. If you've never used Excel, now's a good time to maybe have a little play with it. First of all, it's a nice step up to some of the other things that are coming. Second of all, there will be occasions where it's actually expected that you know Excel by now. Then the last question, we ask you to look at what the advantage is of using material which yields prior to failure. Then the last question in the fuselage stress section, if you look at the pressure differences that you had in the 2 aircraft in questions 1, 2 and 1, 3, and you assume that one is made of aluminum and the other one's made of composite, what does that mean for your design? And don't just give me what you think it means, also explain to me why you think it means that. What are your motivations in that? And we're going to talk a bit more about materials, and we're going to look at the specific material properties. And in 3, the first thing you have to do is actually look at a bit of derivation. So by now you know that some of the criteria that are important for design are strength and stiffness. There are others. And one of the others is weight. And that's what this part of the assignment focuses on. In 3.1, we're going to ask you to look at some equations and work out if you can derive an equation that you should use to calculate which pressure vessel will be the lightest when comparing vessels of the same radius. And to help you do this, I have listed in a table next to this question the density of the different materials that you investigated already in phase 2. Having this formula, and don't worry if you got the formula in 3.1 wrong, I will look at your answers for 3.2 based on your answers from 3.1. So even though this is not for a grade, I wouldn't penalize you extra. I will look at, we call that a continuation error, and I will look at your answers from that. But hopefully you won't get 3.1 wrong because you've understood everything perfectly and you're going to write it out just like that. So after that, in 3.3, discuss a few of the criteria that you could use to select the best combination of pressure vessel, radius and material. Of the combinations that you calculated, which would you consider the best? And why? And then the final question is, you would like to investigate the design of a pressure vessel on a totally different load case. A specific one, the one of bending. So let me show you a little bit what I mean by that. So when we talk about bending it's when we put curves in, or that way. Would your results be different compared to the pressurization load case? And why would they be different? Or why won't they be different? And then you're almost done. Now we're going to look at the snowball effect. To look at the snowball effect, consider a 4-engined aircraft and is flying at a constant speed at a cruising altitude. All the data for the aircraft is here. I don't believe in reading off a slide, so I'm not going to read all the data, but you can leave it up because if you work with friends, it's useful to have a slide where you're all working off the same set of data. So then there are basically 2 questions, and you think, only 2? It is a bit tricky, because question 1, you have to do 5 times. So in question 1, this is about you going through the experience of what happens in a snowball effect. If we reduce the empty weight of an aircraft by 2,000 kilograms, what additional knock-on effect does that have on further weight reduction? This is what the snowball effect is all about. Whereas normally if you roll a snowball downhill, it gets bigger. This one effectively does the exact opposite. If you keep going with your weight reductions, it gets smaller and smaller and smaller. So we want to see at least 5 iterations. Again, you can do this by hand. I'm also fine with you guys working your way through an Excel spreadsheet. By the way, if you're working in a group, don't make the mistake of having one do all the writing up and one do the Excel spreadsheet, because that means that the one who writes up probably has the best idea, because they in detail have followed all the arguments and they look at all the calculations and they see all the final mistakes. And the one in the Excel might be at the short end of the stick, because it's easy to make mistakes in Excel. Actually, it's easy to make mistakes in any programming language. Well, even though the syntax may be right, if you put the wrong data in, 1 dot in the wrong place. As my former professor used to say, garbage in is garbage out. And that rule still applies. So if you are using any sort of code or tabulating software to make plots, let's check each other's work. And that actually goes for all the numerical answers. Check each other's work. Not a bad thing. That's what we do in real life too. We want to see 5 iterations, as I said, and then we should see a nice table of how much the weight reduces. In view of that, the second question, this was a very simplified version of the snowball effect. And we ignored a few parameters. So here's where we want you to reflect on what other parameters you could have used to further reduce weight. And with that brings me to wrapping up. So I said earlier you had to hand it in. And now if you think that I'm really happy if you just take photos of every scratch bit, do yourself a favor, and me, especially if you want feedback, write it out neatly or type it out neatly. I'm fine with handwritten as long as I can read your handwriting. And trust me, I've been here over 20 years. I have just about seen everything. So don't worry too much. But make sure it's in the right order. So not phase 4 before phase 1. So 1, 2, 3, 4. Use drawings, write out everything in full, number equations so that we can follow your logic, basically as if you were reporting to your boss who you would like to convince that you've earned that raise. Once you do that and you have this nicely written or typed out, turn it into a PDF, upload it into Brightspace, and the more readable documents I have, the more likely it is we can give you detailed feedback by the 5 p.m. deadline. If not, we'll try and make it as soon as possible afterwards. So with that, there's just really only one thing for me left to do, and that is to wish you good luck with the assignment. Hope you enjoy it, and looking forward to seeing them.